Hi, I'm Pat Kelly. Okay, in this problem, they give us the nth term of a sequence, and they ask us, is that sequence monotonic? And then also, is it bounded? They further ask us to verify our results with a graphing utility, so you might want to have one of those handy. Okay, let's get into it then. In terms of answering this question monotonic, you should know monotonic means it's either going up, 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 up all the time, or it's going down, 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 down all the time. Now, if I say up, 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 up all the time, let me even rephrase that and say that that's increasing. And down, 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 that's decreasing. And the reason I'm throwing those words at you is because you already have some good tools to use to determine if something's increasing or decreasing. That's your first derivative test. So the way that I would usually approach this type of problem, if I'm trying to answer if this sequence is monotonic, is to try to get into that first derivative test, which means I need a function. So one of the things I'm going to do is kind of rewrite this sequence as a function. I don't mean that literally. This is not replacing that sequence, but the behavior of this function will parallel the behavior of this sequence and vice versa. Let's see if we can figure out what the function's doing, and then we'll know what the sequence is doing. So the first derivative test for increasing, decreasing, of course, starts with the first derivative. X to the minus 1 minus minus x to the minus 2 power. So it doesn't take too much work to realize our derivative is 1 over x squared. And that's really good because it doesn't matter what x is, that's positive. Right? The numerator is always positive, the bottom being squared is always positive. So since f prime of x is always positive, f is increasing. That would be our result from the first derivative test. What that further tells me then is that this sequence is increasing. So hence, the sequence is increasing. I'm writing all that out, but I'm really just asking increasing or decreasing, either or. It's increasing in this case, so we have a yes to this question. They asked us if our sequence was monotonic. Yes, it is. They also asked us if it's bounded. Now, the word kind of describes itself, bounded. Are there some numbers that are trapping every term in this sequence? Is there something that's always below every term? Is there something that's always above every term? Okay, so here's how I'm going to think through that one. Back to that nth term. The smallest number of n that you're going to plug in is 1. So this fraction here would be 1 over 1. That's 1. 4 minus 1 is 3. You'll never go lower than that. So no matter what my term is, a sub n, I know that it's bigger than 3. So 3 is smaller than, possibly equal to, only in that one case when n equals 1. So 3 is a lower bound. There will be no number in this sequence that's lower than 3. And to think about going higher than anything in this sequence, realizing that n goes out to infinity, this fraction is going to go to 0. So 4 will always subtract something, but something tiny, something infinitesimal. So those terms are always going to be smaller than 4. I can even keep that a strict inequality because that will never actually be 0. I wouldn't really even care whether it's a strict or loose inequality in terms of answering this question. Is it bounded? Do you have numbers below and above that are trapping every term in that sequence? And the answer is yes. Okay, so we've answered the two questions doing some paperwork. Now they asked us to verify that with a graphing utility. So let's grab a graphing utility. And I'm going to make sure that I'm in sequence mode and put my function, my sequence, 4 minus 1 over n. And if I graph that, your graph should be showing you several dots. And the pattern of those dots, if you look closely enough, the pattern's going up, up, up. And furthermore, none of those dots are below 3, and none of those dots are above 4. That verifies our results, and we're done with the problem. Okay, thanks, and hope that helped.